Hi lads, I'm just going to talk to you about pingos. Now pingos of course are periglacial features, and the one I'm going to discuss first is the closed system pingo, sometimes referred to as the Mackenzie type, because there is the Mackenzie's Delta in Canada where you find a huge number of closed system pingos. Now what happens is that you need a lake area, and it's as you can see at the top, it occurs in areas of continuous permafrost with talc below. And talc, of course, means unfrozen ground. And the area of blue around here, that's all permafrost. Now what happens is you have a lake above which insulates the ground below, which is why you end up with your area of talc. And what happens is that over time the lake drains, and therefore you do not have the insulating power of the water above. What happens is then the talc starts to freeze, and as it starts to freeze you end up with an ice core in the middle. Now the permafrost around the outside puts pressure on that freezing area of talc, and therefore as the pressure is exerted on it, it pushes the ice up and creates this dome shape here. Eventually what will happen is that ice, it will rise up, and push the land up above it. And what may well happen is that ice will eventually melt, causing the pingo to collapse, and that's what a ruptured pingo is. One thing I've neglected to mention is that when the ice core does expand upwards, that's often due to this advancing permafrost. It's known as hydrostatic pressure, which puts pressure on the surrounding ground, which is why it's pushed up from that ice core. Hopefully that's explained closed system pingos. On the next slide you will see and hear about open system pingos. This is an example of an open system pingo, or an East Greenland type, because they can be found in East Greenland. Now what you've got here in the blue again is our area of permafrost, and here is our talc, or our unfrozen ground. Now what you might have is that water perhaps could have travelled down a hillside and is travelling underneath the permafrost. Now what it finds is a gap or a break in the permafrost. The water then will be put up, due to hydraulic pressure, will be forced into that gap there. And as the water rises, suddenly it will realise it's getting nearer the surface. It'll get colder and colder and colder until it freezes. That is the starting of our ice lens, or our ice core. As more and more water feeds up there, the ice lens then gets bigger and bigger and bigger, again causing this doming to occur at the surface. And as with the closed system pingo, that can obviously then melt, rupture, and you can end up with a lake in the top as well. But that very easily, or very simply explained, is the open system pingo. Key terms you need to remember are that it's hydraulic pressure, which is how the water gets into that crack, and obviously the key term of the ice core or the ice lens. But yeah, hopefully you're happy with open system pingos. Gents, there's a couple of things that you must go and make sure you're aware of. You need to be aware of ice wedge development and ground contraction. You must be aware of nivation and nivation hollows, which is how corries start. You need to be aware of the different types of permafrost, continuous, discontinuous and sporadic permafrost. You need to also be aware about kettles and kettle holes. You must be aware of braided streams and outwash plains. You need to obviously be aware of your different types of moraine. Erratics you need to know about. You need to also make sure that you have an understanding of crag and tail and rock drumlins. You need to be aware of a U-shaped valley and how that's created with truncated spurs, hanging valleys, rock steps. You need to be aware of obviously corries. You need to know exactly how abrasion and plucking occur. And you need to be aware of all of those features. So hopefully there's a video for most of those things, but not all of them. So make sure that you have a good understanding of everything for when your exam comes. Okay, well done lads. Cheers.